Our next topic has something to do with these models over here. So these models show the particles of solids, liquids, and gases. So for solids, it's obvious that the particles are very close to each other, while the particles of gases are far apart from each other. Now what's the reason for this? Why are the particles of solids very close to each other, and why are the particles of gases far apart from each other? Well, this is because of the attractive forces between the particles. These forces can be strong, and some forces are weak. So obviously for solids, the attractive force between particles is very strong. That's why these particles are very close to each other. And for gases, the attractive force is very weak. Now these forces comes from the differences in the charges of particles. Again, a particle can be negative and a particle can be positive. And again, these are oppositely charged particles, and opposite charge will be attracted to each other. Now let's discuss the different forces between the particles of matter. Our topic for this day will be all about intermolecular forces. Intermolecular forces are the forces. These are the forces in between molecules. Let's try to observe first NaCl. So NaCl, or salt. Okay, this one is table salt. So NaCl, or table salt, is made up of two elements. It's made up of Na and then Cl. So if we check on the table of elements, Na, this one is a metal, and Cl is a non-metal. So this one is again metal and then a non-metal. Therefore this one is an ionic bond, and in ionic bonding there is a transfer of electrons. So this sodium will donate an electron to Cl. So after the transfer of electrons, Cl becomes negative and sodium become positive. So again, there is a formation of charge because there is a transfer of electrons. The atom that will receive an electron will become negative, and the atom which loses an electron will become positive. So let's try to simplify this. Again, we have Na, Cl, Na positive, Cl becomes negative. Now, as you observe here, they have different charge. Na is positive and Cl is negative. And again, by rule, opposite charge attracts each other. So here, because they have opposite charge, they are attracted to each other. Now let's say we have another NaCl here, NaCl. Again, the same process, Na becomes positive and Cl becomes negative, and they have opposite charge, positive, then this one is negative, and again, they will be attracted to each other. How about these two molecules here, this NaCl and another NaCl? Are they attracted to each other? Well, as you observe here, there is a point of attraction. So again, on this part, it's positive side, and this one is negative. And again, opposite charge attracts. So this one will be attracted to each other. So there is an attractive force on this part. We call this intermolecular force as ion-ion interaction. We call this as ion-ion interaction because it's the interaction, it's the intermolecular force between an ionic compound and another ionic compound. So that's the first intermolecular force, that's ion-ion interaction. Let's go to another intermolecular force. Let's try to observe HCl. So HCl, hydrogen, that's a non-metal, and Cl also is a non-metal. Again, hydrogen is an exemption, so it's over here, but again, it's an exemption for the metal area. So hydrogen is still a non-metal element. We have a non-metal plus another non-metal element. This one is a covalent bond, and in covalent bonding there is a sharing of electrons, and a covalent bond can be polar or a non-polar bond. And for that, let's check the electronegativity of the atoms here. For hydrogen, the electronegativity is, that's 2.1, and then for Cl, the electronegativity is 3.0. Okay, 3.0. Obviously here there is an equal sharing, so Cl is much more electronegative compared to hydrogen, so Cl becomes partially negative and hydrogen becomes partially positive. So HCl is a polar molecule. It means that the other side has, the two sides have different charge. So let's try to simplify again. Again H, then Cl. Again Cl partially negative and hydrogen partially positive. Let's say we have another HCl molecule here. This one is partially positive and this one is partially negative. Is there an attraction between these two molecules of HCl? Again, for that, we need to look on the different charges. So here we have a partially negative side, and this one we have partially positive side. And again, these are oppositely charged, and therefore they will be attracted to each other. So this attractive forces, we call this one as, this one is a dipole-dipole force. A dipole-dipole force is between a polar molecule and another polar molecule. And again, ion-ion is between an ionic compound and another ionic compound. So this one is the second type of intermolecular force, dipole-dipole force. Now, which do you think is much stronger? Is it the ion-ion or the dipole-dipole force? Well, as you observe here, in dipole-dipole force, there's only partial charges. Because again, here they are sharing electrons, and the partial charges are only because there is an equal sharing. But here, there is an actual transfer of electrons, so there is a full charge. So again, there's a full charge when there is an actual transfer of electrons. On this case, there are partial charges because there is an equal sharing of electrons. So we can say that this one is much stronger because it involves full charge compared to this one, because this one only involves partial charges between molecules. Again, that's the two first intermolecular force, the ion-ion interaction, and then the dipole-dipole force. Let's have another compound. Let's have H2O. Okay, H2O, let's try to identify whether this one is first hydrogen. This one is a non-metal, and the same thing for oxygen, it's also a non-metal. So it's a non-metal plus non-metal. Therefore, this one is a covalent compound. Now, if it's a covalent compound, let's identify whether this one is a polar or a non-polar compound. Hydrogen, the electronegativity is 2.1, and for oxygen, the electronegativity is 3.5. Okay, let's put that here, 2.1, then 3.5, 3.5. Obviously unequal sharing, so Cl becomes partially negative, hydrogen partially positive, and oxygen here partially negative. And again, if you observe here, there are two different sides. The top is partially positive and the other one is partially negative. So we can say that H2O molecule is a polar molecule. Okay, let's again, this one is partially positive. Positive. This one is partially negative and another partially negative. Let's say we have another H2O molecule here. Again, the same thing, partially positive hydrogen, partially negative, and partially negative. Now here we have a polar molecule and another polar molecule. So as we discussed, this one is a dipole-dipole force because it's between a polar and another polar molecule. But on this case, this one is special. So we have a different category for this. This one is a stronger version of other dipole-dipole force. We call this force as hydrogen bonding. So it's hydrogen bonding when a hydrogen is attracted to either fluorine, oxygen, or nitrogen. That's fun. Again, F for fluorine, O nitrogen, and N is nitrogen. So here we have this hydrogen, partially positive, can be attracted to this partially negative side of this molecule here. So again, this one is partially positive and this one is partially negative. Opposite charge will attract. So this one will attract these two molecules together. And again, on this case, the hydrogen is attached to an oxygen. So this one is a hydrogen bonding. That's the third category. This one is a hydrogen bonding between a polar molecule, but here the hydrogen is attached to fluorine, oxygen, and nitrogen. Let's go to the last type of intermolecular force. Let's observe N2. So N2 is, this one is a covalent compound because both are nonmetals. Then if you look on the table of elements, nitrogen, the electronegativity is 3.0. Okay, that's 3.0, 3.0, 3.0. Here, it's equal sharing. So on this case, it's a non-polar molecule. So walang formation ng partially negative side. So here, walang charge ang molecule. It's just this one, N2. Is there a way that this molecule can be attracted to this one? But, so again, on this case, there are no partial charges. So walang side na partially negative and walang side na partially positive. Actually, on this case, there is a very weak force, and this force, we call this one as a dispersion force. This is due to the dispersion or the movement of the electrons around the molecule. So again, here, if we try to draw this one, this nitrogen, it has 5 valence electrons. Then this one also have 5 valence electrons. And again, these valence electrons are not stable, or they are not permanent on their place. They are constantly moving around the molecule. Let's say, for example, at one moment, let's say, lahat ng electrons is they stayed on this side, for example. So on this case, this part has more electrons compared to this one. This will give a slight charge, so it will give this side a slightly partially negative charge, and on this case, slightly partially positive side. Kasi on this case, lahat ng electrons is on this side, and on this case, on this side is there's less electrons. And let's say the same thing happened to another N2 molecule. Again, it has electrons around, and let's say, for example, at one moment, all the electrons are over here. At this moment, this side becomes partially negative, and this one becomes slightly positive. Now, in this case, there is a slight charge. Here we have a partially positive side, and this one we have a slightly negative charge on this case. And again, there's opposite charge, and this one will actually attract this one. We call this force as a dispersion force. This one is the weakest force and is only temporary. Dispersion force. So dispersion force occurs between a nonpolar and another nonpolar molecule.